Wildcats. Today we're looking at Wednesday, September 26th, Solving Absolute Value Inequalities Part 1. That's going to be on part page 12. And we're looking at Thursday, September 27th, Solving Absolute Value Inequalities Part 2. And that's not going to be in your journal binder. So you would update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. Now to complete the notes, you need notebook paper. I recommend College Rule. Solving Absolute Value Inequalities Part 1. That's going to be on journal page 12. Conjunction, or connected and and. A conjunction is a compound statement formed by joining two statements with a connector and. So the key about if it's an less than, it's an and, your solution will be, and the X will be between the inequality symbols, okay? The solution also could be empty set or no solution. All right, finish up conjunction notes. All right, now let's look at disjunction. Disjunction, or disconnected or. A disjunction is a compound statement formed by joining two statements with a connector or. So the key is, if it's greater than or greater than or equal to, it's going to be an or solution. So X is less than or X is greater than, or X is less than or equal to, or X is greater than or equal to. The solution also could be all real numbers. All right, solving absolute value inequality steps. Step 1, isolate the absolute value. Step 2, graph the left side. Step 3, graph the right side. Step 4, sketch the solution on the number line. And step 5, write the solution. You would update your notes. All right, now your notes are updated. Let's take a look at the examples, which again, this page is going to be on journal binder page 12. Okay, solve the absolute value inequalities below. Show your answer on the number line. So first step is isolate the absolute value. So we're going to subtract 2 from both sides. That's 0. So we get the absolute value of X equals, or well, less than or equal to 6. Now the next step is to graph the left side. To do that, we need to make a table. So when X is negative 2, we do the absolute value of negative 2, which is 2. When X is negative 1, the absolute value of negative 1 is 1. When X is 0, the absolute value of 0 is 0. Okay, when X is 1, the absolute value of 1 is 1. When X is 2, the absolute value of 2 is 2. All right, so now we graph those points. So negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. Now that forms a V, so we know that these points continue this direction in maintaining the V shape. Okay, now because there's a line underneath, we know that it's a solid line. Now the next step is to graph the right side, which is 6. We have a horizontal line of 6, so 1, 2, 3, 4, 5, 6. So there's your horizontal line of 6. This is the absolute value of X. Now, this says less than or equal to, so we're looking for when it's less than the horizontal line of 6. So that's this area right here. So we know the intersect here, it's a solid dot because of the line underneath. But when we solve, we're not looking for the Y value, we're looking for the X values when you solve. Okay. So we go down to find the X value here and here. So the X value is negative 1, 2, 3, 4, 5, 6. So X is negative 6. And X is 1, 2, 3, 4, 5, 6. Now, the next step is to sketch on the number line. So first off, here's 0. Now, the reason why I put 0 is because it separates the negative and positive. So we have a closed circle at negative 6, and we have a closed circle at 6. So notice how I'm keeping this kind of lined up. So here, you see here, this is where it's shaded. So this is where it's going to be shaded between those points. Okay. Now we know from our notes, if it's less than, then it's an and statement, and it's going to be between. So since it's less than or equal to, there's our solution right here. Okay? So this is an and statement. So we know it's -6 less than or equal to x less than or equal to 6. All right, so now let's take a look at example 2. So first step, isolate the absolute value. So we're going to add 4 to both sides. So that's 0. So then you'll have the absolute value of x less than 4. Now you could make another table, but in essence, the absolute value is the same. So we could actually just use this table as well. Okay, so we know -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. And again, they make the V shape, so you know that it's going to be V all the way this way. Now, because it's less than no line underneath, we know it's a dashed line. So every other point, I'm going to put a dash. Okay. Now we graph the right side, so that's a horizontal at 4. So 1, 2, 3, 4. So this is 4. This is the absolute value of x. Now we're looking for when it's less than, so that's this area right here. This is when it's less than that horizontal line at 4. And in this case, because it's less than no line underneath, this is an open circle here and an open circle right here. And then we're going to find the x value. So we go down to the x. So x is 1, -1, 2, 3, 4. So x is -4. And x is 1, 2, 3, 4. So again, here's my 0, -4, open circle on the left side, and +4, open circle on the right. And just like it's shaded between the points, you're going to shade between the points on the number line. So that's -4, 4. And we know it's just like example 1, except for instead of equal to, it's this less than. So -4 less than x less than 4. And let me draw a line separating the there. All right, so finish up examples 1 and 2. All right, let's look at example 3. All right, so step 1, isolate the absolute value, which we did. Step 2, graph the left side. So now this we're going to shift. So it's +4 means it moves left 1, 2, 3, 4. That's our new vertex. And we're going to graph by direction. Let me fix the blurriness there. Now, what I mean by direction is looking back up here, in the parent function, these are the points, but they can also be the directions if we move the absolute value. So we're going to use these as direction now. -2, 2, -1, 1. HK is your new vertex. It was 0, 0. Now it's here. 1, 1, and 2, 2. Okay. So from here we go left 2, up 2, left 1, up 1, right 1, up 1, right 2, up 2. And you can see that gave you the V shape. And we know that we can continue the points here. Now, if you had trouble graphing by direction, you can also graph just using your calculator. Okay, so if you go to graph, and actually I don't like going to graph because there's stuff in there. I'm going to go to new document, no, add graph. And then to get the absolute value, we press the button to the right of 9. So that's this right here. And then we type x plus 4. And we're just graphing the left side, so we press enter. Press Control T, and then I can get my point. So go all the way to negative 10. So negative 10, 6, negative 9, 5, negative 8, 4, negative 7, 3, 6, 2, negative 5, negative 4, 0, 3, 1, and so on. Okay. So that's, you can either graph by direction using your calculator. Okay. All right. Either way, we have the left side graphed. Now we graph the right side, which is a horizontal line at 3. So that's 1, 2, 3. Oh, hold on. I'm sorry. I almost forgot. This is a dashed line because there's no line underneath. Okay, now we have a horizontal line at 3. Now, in this case, it's greater than. So we look at where is it greater than the 3? Well, here it's greater than, and here it's greater than. Okay, so we look at the point where they intersect, and that no line, so it's open circle. So open circle here, and open circle here. And then we find the x value. So the x value is here and here. So our solutions are negative 1, 2, 3, 4, 5, 6, 7, negative 7. So x equals negative 7, and x equals negative 1. So again, I'm going to try to keep these lined up. So here's where x is 0. And then we have, actually, well, I'm sorry. No, that's not where x is 0. X is 0 right here. There we go. So we have an open circle at negative 1, and we have an open circle at negative 7. And then you see the shaded to the left of the point and the right. So the shading is here and here. All right, so we know from our notes that when it's less than, or I'm sorry, when it's greater than, that our solution is going to be x less than and x greater than. Okay? So that's x is less than negative 7, or, because this is an or statement when it's greater, so or x is greater than negative 1. All right, to finish up example 3. All right, let's take a look at example 4. So again, we're going to graph by direction. So we first move the vertex. So minus 4 means we go plus 4, 1, 2, 3, 4. And then we graph by direction. And we know from example 3 that our directions are negative 2, 2, 1, 1, h, k, because that's our new vertex, 1, 1, 2, 2. So left 2 up 2, left 1 up 1, right 1 up 1, right 2 up 2. Now, if you had trouble graphing by direction, you could also graph using the calculator. So we'd go to New Document, No, on New Document, Add Graph, and then to get the key, if I can speak, the absolute value button, which is next to 9, it's right here. And then we do x minus 4, Control T, and then we can graph a point. So I'm going to go all the way to x is negative 10. Now, I can't graph that point because it's too high. Can't that, but I can graph negative 6, 10. So negative 1, 2, 3, 4, 5, 6, 1, 2, 10, 10's up there. Negative 5, 9. Negative 4, 8. Negative 3, 7. Negative 2, 6. Negative 1, 5. 0, 4. 1, 3. 2, 2. 3, 1. 40, 51, 5 or 62, 73, and you can kind of get where the shape is going. Okay, so there's two ways to graph. Now it's a solid line because there's a line underneath. Now we know when it's greater than, it's an or statement. Okay, now we graph the right side, which is a horizontal line of 3. So 1, 2, 3. Okay, now we know it's greater than, so we're shading up greater than the 3. So that's here and that's here. Now we know that since we're line enough, it's solid closed circle right here and here. We're looking for the x value, so we go down. So our solution is x equals 1 and x equals 1, 2, 3, 4, 5, 6, 7. X equals 7. Now our 0 lining up with the graph is right here. And then we have a closed circle at 1 and a closed circle at 7. And you can see from the graph that we shade to the left of 1 and we shade to the right of 7. So our solution is x less than or equal to 1 or x is greater than or equal to 7. That's a long bell. All right. So at this point, if you understood the examples, then what you need to do on Wednesday is start working on the assignment, okay? And then, so start working on this assignment, which this is actually part, oh, wait a second, whoa. There's more examples. We should probably do those examples. All right, so take that back. This video is going to take most of the class, okay? So we're going to continue on, and you should be able to finish this video before class is over. And then I'll explain, once we're done with these examples, I'll explain what we're going to do with the last page, okay? All right, so example 5, okay? So first step is isolate the absolute value. So we're going to add 5 to both sides. So that starts with 2, absolute value x plus 3 less than, that's 12. Still not isolated, so we're going to divide both sides by 2. So now you're left with absolute value of x plus 3 less than 6. All right, now the absolute value is isolated. Okay, so now we graph the right side, so that's plus 3. So plus 3 means you go left, so 1, 2, 3. And then you can graph by direction. Okay, so we know the directions are -2, 2, -1, 1, HK, 1, 1, 2, 2. So from here we go left 2 up 2, left 1 up 1, right 1 up 1, right 2 up 2. If you didn't understand how to graph by direction, you can graph using the calculator. So we go to on, new document, no, add graph, and you should know the button by now for the absolute value. X plus 3, Control T. Now we go all the way to x is -10. So we can graph -10, 7. So -10, 1, 2, 3, 4, 5, 6, 7. And then -9, 6. -8, 5. -7, 4. -6, 3. And that's already graphed. -5, 2. -4, 1. -3, 0. -2, 1. -1, 2. 0, 3. And by then you kind of see the shape. Ooh, made a mistake there. It's less than no line underneath, so it's actually dash line. So I can just erase a bit of it to make it a dash line. and then my dashed line right here. Okay. Now we graph the right side, which is a horizontal line at 6. So 1, 2, 3, 4, 5, 6. Okay. Now it's less than, so we shade everywhere it's less than, which is right here. Okay. There's no line, so we have an open circle right here and right here where they intersect. And then we try to find the x value. So we draw a line down. So our solutions are x equals -9 and x equals 1, 2, 3. All right, so now here's our, when x is 0, so we have an open circle at 3, and we have an open circle at -9. And since it's shaded between, we shade between here. And then our solution is -9 less than x less than 3. So scrunch there, but it's there. All right, example 6. Now, this video is long, but I assure you, this is one of the few times this video is really long. Most of the videos won't be this long, but there's just 6 examples that you have to see in order to see all the different types to understand these problems, okay? All right, example 6. So the first thing you do is isolate the absolute value. So we subtract 5 from both sides. That becomes 0. You get 1/2 value of x minus 3 greater than or equal to 6 minus 5 is 1. And then we have to multiply both sides by 2. And the reason being, 2 times 1/2 is 1. Well, it becomes 2 divided by 2, which is 1. So you're left with the absolute value of x minus 3 greater than or equal to 2 times 1 is 2. Now that the absolute value is isolated, now we graph the left side. So we go to the right 3, that's our new vertex, and we graph by direction. Which we know the directions are -2, 2, -1, 1, k, 1, 1, 2, 2. So from here we go left 2 up 2, left 1 up 1, right 1 up 1, right 2 up 2. And then if you didn't understand how to graph by direction, you can graph using the calculator. So we go to on, new document, no, add graph, absolute value, x minus 3, control T, and then we're going to go all the way when x is -10. Can't use that point, it's too big. Can't use that point. -7, 10. So -1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then -6, 9, -5, 8, -4, 7, -3, 6, -2, 5, -1, 4, -0, 3. We've had 1, 2, 2, 1, 3, 0, 4, 1, 4, 2. And you can kind of already get the shapes here. All right. Now, because there's a line, it's a solid line. And then now we graph the right side, which is a horizontal line at 2. Now, in this case, it's greater than, so we shade above the line. So here and here. Now, because the line needs it's a solid dot here and here, and then we're looking for the x value. So we draw a line down. So it looks like x is 1 and x is 1, 2, 3, 4, 5. So now we graph. Here's when x is 0. And then it looks like we have a closed circle at 1 and a closed circle at 5. Now, when it's greater than, we know it's an or statement. Okay, so we know we're shading, just like the picture, to the left of 1 or to the right of 5. And so our inequality is x is less than or equal to 1 or x is greater than or equal to 5. All right, so finish up example 5 and 6. All right, now let's take a look at example, I'm sorry. Okay, that should be a 7 and that should be an 8. There we go. So example 7 and 8. All right, so step 1, isolate the absolute value, so it's isolated. Now we graph by direction, so we move the vertex. +1 means we go left 1, now we graph by direction. Okay, so we know directions are -2, 2, 1, HK, 1, 1, 2, 2. Okay, so from here we go left 2 up 2, left 1 up 1, right 1 up 1, right 2 up 2. Now, if you didn't understand graphing by direction, we can graph using the calculator. So on, new document, no, add graph. So then we do absolute value of x plus 1, or absolute value of x plus 1, control T. Now we're going to go all the way to when x is -10. So -10, 9. So -10, 9, -9, 8, -8, 7, -7, 6, -6, 5, -5, 4, -4, 3 we have, and we have all the way to -1, 0, 0, 1, 1, 2, and then 2, 3. And then by then you kind of see the shape. There's no line, so it's a dashed line. Now we have a horizontal line at -5, so -1, 2, 3, 4, 5. Now it's less than, so we say below the -5. Now you see that at no point is any of the graph shaded, so this is no solution. So your graph, nothing would be shaded. Okay, so now let's take a look at example 8. All right, example 8. First step, isolate the absolute value. It's isolated. Now, tell you what, let's make this greater than or equal to. All right, so now we graph by direction. So we move the vertex, so +1. Okay, then we graph by direction. Okay, which we know is -2, 2, -1, 1, k, 1, 1, 2, 2. So we go left 2 up 2, left 1 up 1, right 1 up 1, right 2 up 2. Now, if you didn't understand graphing by direction, we can graph using the calculator. So we go to on, new document, no, add graph, absolute value x -1, control T, go to all the way when x is -10. Can't graph that, but we can graph -9, 10, -8, 9, -7, 8, -6, 7, -5, 6, -4, 5, -3, 4, -2, 3. We have those points, and then you can see this shape is already here. And since it's a line underneath, we know it's a solid line. And then we have a horizontal line at -5. So 1, 2, 3, 4, 5. But in this case, we shade greater than, so we shade everything above the line. So you can see the entire graph is shaded. So this is all real numbers. So you would shade the entire number line. There's your solution. All right, so at this point, if you understood our examples, I would start working on the assignment. If you need me to go over some of the examples again, I can also do that in class. So, but in essence, what I want to do is, this is a 30-minute video, so long video. This is going to take you most of the class, okay? If it did, that's fine. I'll give you 25 minutes to complete part 2 in class on Thursday, September 27th, okay? And then at that point, I'll check for completion, and then we'll go over this together, okay? But I'm hoping that you're watching this on Wednesday and you finished it and you started this assignment and you're going to finish some of them. And that should say problem number 2, okay? So again, once you've done with the video, start working on problems 1 through 4, and just know you'll have 25 minutes on Thursday to finish it, and then I'll check for completion. Okay, so with that, have a wonderful Wildcat